Everyone, Mrs. V here, and today we are going to start our series on different types of chemical reaction. Today we're going to be looking at combination reactions, which are also called synthesis reactions. So let's get our whiteboard on and get started. Okay, so there's an enormous variety of chemical reactions that can occur between substances. To be able to actually study this big variety, we're going to need to break it down into some general classes of reactions. So when we've done that, we can actually write a general equation for the reaction, and this is going to help us predict what occurs in the chemical reaction. So we're going to look at combination reactions, decomposition reactions, single replacement reactions, double replacement reactions, combustion reactions, and acid reactions. Today, we're going to look at our first class, the combination reaction. These are also called synthesis reactions. And they're pretty easy to recognize because what happens in a synthesis reaction is two substances react to make one substance. And so they're very easy to recognize because there are two reactants, but only one product. So that makes them extremely easy to recognize. Now, these can happen between metals and non-metals. And when you do that, you get an ionic compound made of ions. And you remember, ions are charged atoms. Or sometimes ions can be a group of atoms that have an overall charge. So that's between a metal and a non-metal. When two non-metals react, we get what's called a covalent compound. And a covalent compound forms either molecules or sometimes giant covalent lattices. So non-metal and non-metal gives you covalent. Metal plus non-metal gives you ionic. Metals don't react with other metals in a chemical reaction. You can actually make a mixture of different metals, which is called an alloy, but it's not a chemical reaction. All right, so what you might notice in our example here, when we have sodium reacting with chlorine, our product is not called sodium chlorine. Our product is called sodium chloride. Whenever we have an ionic compound forming, the non-metal name gets chopped off, it gets truncated, the end gets taken off, and we put this ending IDE on that. So that shows that it's a negative ion that is just a non-metal atom. Okay. We also name covalent compounds with this ending of "ide", but in a covalent compound, we actually have little prefixes to say how many of each type of atom is. So CO is called carbon monoxide, whereas CO2 is called carbon dioxide. If there's more than one of the first atom, you use a prefix for that as well. So if we had something like N2O4, that's called dinitrogen. And the prefix for 4 in chemistry is tetra, so tetraoxide. Normally, though, that just becomes tetroxide. And so that's the different ways that we name ionic compounds and covalent compounds. To learn how to use a general equation, we're going to do a few examples. So this little 2 here, when I've said ion 2, I technically shouldn't do that. Technically, when a metal is just, a transition metal is just an element, it doesn't have its Roman numeral. I just put that there so you'd know which ion to use. So iron and sulfur, that's a metal and a non-metal. So we're going to make an ionic compound, and that ionic compound is going to be called iron 2 sulfide. Notice that sulfur is spelled with an F, not a PH. The old way to spell sulfur was with a PH. Now this is not an Americanization. This is a recognition of the original Latin spelling, and that has been accepted by the Royal Society of Chemistry. In Australia, we've been spelling sulfur with an F since 1981. So sulfur has an F. All right, pause the video and try the next one. Okay, potassium plus oxygen. Remember, the metal name does not change, but the non-metal, the end gets taken off of the name and "-ide" put on. Next one, the metal name is chlorine. The non-metal name's chlorine, the metal name's calcium. So the metal name stays the same, and we chop off the ending of the chlorine and do chloride. I want you to pause the video and I want you to try the rest of the examples. No, like really pause it. Okay, let's check your answers. Did you get rubidium fluoride? It's fluoride. Just going to try that one again so that I can really emphasize the spelling here. Rubidium fluoride, zinc nitride, magnesium iodide, barium bromide, cesium phosphide, strontium oxide, and lithium, this one's selenide. How did you go with those? Did you get them all right? You've just taken your first step in writing chemical equations because you have used a general equation to predict what happens in a chemical reaction. That's all for today. I am going to see you guys in the next video.